Convergent boundaries are one of the three types of plate boundaries in the theory of plate tectonics. The three types of boundaries are convergent boundaries, divergent boundaries, and transform boundaries. Convergent boundaries are also known as destructive boundaries because they destroy old crust. Each plate boundary type is characterized by features that can be observed at or near the Earth's surface. These features are volcanology, which deals with volcanoes, seismology, which deals with earthquakes, geochronology, which deals with the age of the Earth's crust, and topography and bathymetry, which deal with the height of the land and the depths of the oceans, respectively. Convergent boundaries, just like the other two types of boundaries, have special characteristics that help us to identify when we're looking at a convergent boundary. Let's look at each of these features and describe what we would see at a convergent boundary. Many of the features present at a convergent boundary are the result of the subduction zone. When two plates meet, typically one of them is forced underneath the other. This is known as a subduction zone, and it's responsible for a number of the features we see at convergent boundaries. Convergent boundaries are known for having a line of volcanoes asymmetric to the plate boundary. This means that they are on one side of the plate boundary. This happens because as the subduction zone is forced deeper into the Earth, it heats up, melts, and causes volcanoes along one side of the plate boundary. Convergent boundaries are known for having earthquakes that extend from the boundary and become increasingly deep. The variation in the depth of these earthquakes is caused by the subduction zone. As the plate that's part of the subduction zone is forced deeper and deeper into the Earth, the earthquakes originate from deeper underground, which often causes them to be of greater magnitude or greater strength. Since convergent boundaries are also classified as destructive boundaries, they're known for destroying old crust, which is the opposite of divergent boundaries, which create new crust. Topography at a convergent boundary is characterized by having mountain ranges along one side of the plate boundary. These mountain ranges correspond to and are caused by the volcanoes that we discussed earlier. Convergent boundaries are known for having a bathymetry that shows a deep trench at the point of the plate boundary. This happens because as two plates meet at a convergent boundary and one of them is forced under into the subduction zone, they catch on each other and the second plate is also dipped downward to create this deep valley usually found in the ocean. One famous convergent boundary happens near the Andes Mountains, where the South American plate and the Nazca plate interact. The Nazca plate is forced underneath the South American plate at this convergent boundary. This causes the Andes mountain range to be formed on land and a deep trench to be formed in the ocean. The plate boundary between these two plates, the South American and the Nazca plate, represents all of the key features commonly found in convergent boundaries.